everyone, and welcome to Electronic and Computer Engineering, your first day. So great to see that you have chosen this course. Thank you very much for choosing this course. I hope it'll be a very happy and a productive time for you at NUI Galway. My name is Martin Glavin. I'm the Program Director for Electronic and Computer Engineering. So if ever you need any support, any help, any advice, anything at all really, come to me. I'm the person who's hopefully going to be able to help and support you, and I suppose indeed, like any of the staff members at NUI Galway, we're all here to help and support you and get you through the course. But I suppose my particular responsibility is for electronic and computer engineering students. I won't see that much of you in first year, because everybody in first year does a common first year program. So everybody, regardless of whether you're from mechanical or civil or biomed or any of the other courses, everybody does the same stuff. So that's kind of taken care of by our first year coordinator. But I'm still your program director, but really from second year onwards through the program, that's where you'll start to see more of me, and that's where I'll be spending a little bit more time with you. But for now, my job here today is just to try to give you maybe a little bit of a sense of what's coming down the tracks to you, and even beyond the course, what some opportunities that you might have beyond studying with us at NUI Galway. I always think it's nice to have some sense of what the future might hold, and there are good things in the future for graduates of electronic and computer engineering. So just to maybe give you a sense of some of the terminology, you're joining the discipline of electrical and electronic engineering. So it's just a group of us academics who teach on the electronics courses. But your program is electronic and computer engineering. So we also have a sister program, a taught program called electrical and electronic engineering. So it can be a little bit confusing. There's the EEE course, and then there's the EEE discipline, which is the group of academics. So you're part of the discipline of electrical and electronic engineering, but the course that you're doing is electronic and computer engineering. So just try and clarify that. Regardless of which course you're on, the job for us here is that we get you a qualification that will secure you a successful professional engineering career, get you a good job, lots of money, nice, good working conditions, and I suppose inspire you to learn about the technologies and develop some new technologies, travel, see the world, and do some really good things for society with the skills that you develop. I suppose many people have a perception that people who study electronics end up just working in the electronics industry. Of course, you can go and work in the electronics industry, and there's lots of electronics in Ireland and around the world. But really, electronics and software, the electronics, the technology that we develop is used in so many industry sectors that you can actually find yourself working across a huge breadth of different industry sectors. So you're not just being funneled into just kind of a single path. In many ways, the entire world opens up to you with the skills that you'll develop in this program. So the future is very bright and very positive. It's going to be a little bit restricted for the first year with COVID, or maybe even part of next year. But hopefully, beyond that, as you graduate from this program, you'll be back into the I suppose the post-COVID era, where everything has opened up, and hopefully we're all back to some version of normal. Just to give you a kind of a sense of who's going to be around you and the lectures and all that kind of thing. For the first year, everybody more or less does the undenominated program. Every first year student does exactly the same content in engineering. So that's great. You get to meet other students in other programs, and you get to appreciate and understand the various different challenges of the other types of engineering. So it's a really good opportunity in first year to learn a little bit about lots of different types of engineering. For those of you on the electronic and computer engineering stream, the nice thing for you is that in second year you'll be taking all of your courses with the electrical and electronic engineering program. So you'll all be doing the same stuff in second year, EEE and ECE. So you'll be in the classes with EEE quite a bit. Actually, you'll still be in quite a number of classes even through third, fourth and fifth year, but For second year, they're completely identical. So that because there's so much commonality then in the first 2 years, it means that you do have some flexibility if you wanted to make some choices, or if you wanted to switch over to the electrical program, if you have enough points, then of course that's completely feasible. So there's an opportunity for students in electronics to maybe move between the two programs. In third and fourth year then, we'll be asking you to specialise into your electrical or electronic computer engineering stream. So you'll be choosing, I presume, for yourselves to stay on the electronic computer engineering stream, where you'll do some more specialised software, primarily software modules taken with the IT department and with ourselves as well. And also in fifth year, you can also continue on, get your fifth year qualification, your master's qualification in electronic and computer engineering. So all of those options lie there, both for electrical and electronic and computer engineering. So that's where you specialise. Job opportunities, really, just pretty much name the company and there's job opportunities there for you. You can see it ranges kind of everything from energy to the Intel, the electronics industry, Ericsson and communications, electricity and kind of green energy, analog devices, kind of electronic device manufacturer, design and manufacturer, Valeo, they design car technology, Amazon, everybody knows, Avaya and other communications, Google, everybody knows, Fidelity Investments. This is in the financial services sector. So you can see that there's quite a breadth of different types of companies. Of course, you have the likes of Facebook and EA Games and all those guys. And there are more jobs out there than all the graduates from all the universities in Ireland could fill. There are just so many jobs out there, as that it really is a very student-friendly, opportunity-rich environment. And the industry sectors, really, it's the A to Z of industry in automotive, aviation, comms, energy, financial, gaming, healthcare, and the development of biomedical devices for medical care, huge. You can go into media, microelectronics, software, agricultural technology, autonomous vehicles, drones, smart cities, you name it. These technologies of the future are where you'll find huge opportunities. I'll talk just a little bit more, just to even give you a sense of the global scale of the industry that you're now going to be a part of, and that you're already a part of, having chosen to take this program. Another opportunity that some people sometimes don't really consider straight off the bat is that you can start your own company. A number of our graduates have started their own company very successfully over the last few years. So things like Blue Tree Systems and Exordo, very, very successful company, startup from Galway, Shipwright. Loads of different companies there. On average, I think about one student per year starts up a company. A few will start up companies, but one student starts up a company that will keep going and will be trading a few years after graduating. Of course, it's people decide to move from between companies or start up and sell off their companies for various reasons. But a measure of success is a company that makes some money, hires some people, and keeps going for a few years. These companies, some of them started up, some of them moved on, some of them changed, some of them were bought, but they were all started up by graduates of our program. We're very proud of that fact, that you are given the skills and also the confidence to go, and if you have this idea that you feel is commercially viable, then you can go and commercialize straight away. So 1 to 2 graduates start a company every year. That's pretty much been going on for many years. So in electronic and computer engineering, we say it's where software meets hardware. It's the magic that happens when you have really well-designed electronic hardware, and then you write that software that makes the hardware do something cleverer, faster, more efficient, better, new. Thinking of things like iPhone releases, they're talking about new iPhones coming out and new iPads and the software updates for them. And this is the world that you're now entering into. So in terms of an electronic computer engineer, you really are the fusion of software and hardware. And you will design, or you will have the capability to design computers, smartphones, gaming systems, medical devices, autonomous cars, custom chips, even the internal chips that drive these things. So you'll have the skills to design the various components and put them together. And you'll also have the skills to program them and make them do something really, really useful. So whether it be a new type of an app for a smartphone, or maybe combining gaming on smartphones, or whether it's a medical device, a wearable device that you put on your body and measure some parameters of how you go about your daily life. You'll have the skills to either work in the hardware, work in the software, or I suppose find that kind of magic where the two come together. So that's a huge opportunity for you as well. So there's lots of technologies emerging. You might think that you have seen a huge pace of change, or a huge number of newer technologies released over the years, and you kind of wonder what's next. Well, honestly, what's coming down the tracks over the next few years is going to just blow away everything that we've seen over the last 10 years. So there's lots of very exciting things to come. Some sample projects that you might find yourself doing as you go through the course, maybe building computers. So here's an example of some guy building a supercomputer to treat cancer. This is a student a few years ago did a project using brainwaves to control the computers, and also got it to control a little remote-controlled car and a drone and stuff like that. Another thing is detecting vulnerable road users, so using sensors for cars to detect people at night time using infrared sensors. So this is a project that ran a few years ago, and we have sensors from the likes of BMWs and things like that in our labs as well. So you get opportunities to play with some really up-to-date current technology as well, particularly in projects as you go through years 3, 4, and 5 when you do your projects, or when you do some more advanced projects. Of course, you'll be doing some simpler projects in first and second year as well. So project is a big area of this course, where we really like to get our students to get hands-on building stuff and programming stuff, and developing cars and drones and sensor systems and computer systems, all that kind of stuff. There's also our sister program, electrical and electronic engineering. So I suppose the electrical program is a little bit more focused on energy, and how it's produced and how it's managed and how it's used and how it's transformed and all that kind of stuff. So there are subtle differences between the two programs. Electrical, you focus a little bit more on the electrical energy side of things. The electronic computers more on the software and communications and stuff like that. So I kind of think the electrical guys, they kind of move energy. The electronic computer engineering students kind of move data, and that's kind of where the differences lie. So some of the opportunities that you're going to see, Internet of Things is just vast. We're talking about putting sensors in, all across cities, sensors on farms, on monitoring crops, monitoring air quality. There's literally hundreds of computers in things like cars and buses and on buildings, all that kind of stuff, and everything just kind of pulling data and trying to understand the environment and make the world kind of a smarter place through kind of networking everything together. Autonomous electric vehicles and smart cities is a huge technology. In some ways, it might sound as if electronic or autonomous vehicles have kind of disappeared, that they're not going to arrive after all the talk there was about them. But actually, the companies have literally in a call this morning where we were talking about this, and so many of the vehicle companies now are totally committed that in the next 10 years you will be seeing the cars getting increasingly intelligent, more sensors. You'll see the cities themselves getting smarter, more sensors, more cameras, and the vehicles and the infrastructure, the lights and the train programs and the timings and the car park availability, all of that sharing information so that autonomous vehicles can more safely and more efficiently move around the cities. Wearable electronics is going to be huge. With an aging population, we're going to need more and more stuff to monitor us and try and keep us out of hospital as long as possible, because the hospitals won't be able to keep us in larger numbers as we get older. There's always going to be new mobile phones and new personal wearable technology. Renewable energy and smart grid is going to be huge. And wireless power communication and charging and more low power, battery powered devices also going to be a big area. And another area that I see huge opportunities and huge changes coming is in smart agriculture, where the old ways are going to have to be updated to allow for smarter vehicles, better management, more efficient management of the land, replacing sprays with machinery that can tend to crops and tend to animals. So there's huge changes coming in that space. The world you'll be entering, even in 2020, you're talking about 4 billion people connected. So every one of those are sharing data. About $4 trillion money being moved around as a result of the electronics industry. About 25 odd million apps, 25 plus billion embedded and intelligent systems. So basically 25 billion computer systems in the world. And that number growing exponentially all the time. 50 trillion gigabytes of data. They say that the vast majority of the data that exists in the world has been created over the last 10 years. And that's just kind of constantly growing all the time. So how do we manage all of that data? How do we communicate, 5G communications with phones, all that kind of stuff. So lots to do, lots of really cool technologies coming down the tracks, and really that's where the opportunities are going to abound for yourselves. So I suppose this is kind of how you fit into the world. Really, you will be making some contributions, whether it's traffic monitoring or in vehicles or in the home, healthiness of the home, all the different sensors and communication devices in the home, managing energy, the flow of energy, maybe in industry, either supplying equipment to these other technologies, or maybe just keeping industry going in its own right. You'll also be, there's things like security and just even the communications world. I mean, just the amount of infrastructure and work that needs to be done to get everybody connected with 5th generation, 6th generation, 7th generation mobile phones. And you hear a lot of talk about cloud computing and artificial intelligence and big data. So in many ways, you are the source of the big data. You are the people who are going to develop these sensor systems that are going to generate all this huge amounts of data. But data in itself is no good. It's only when you turn it into information that's when it really becomes something of value. And that's where processing and software and controlling all of these things and systems that can learn from themselves. The autonomous vehicles that will learn from their environment and not make the mistakes that humans might make as they drive around. So huge, like I say, huge opportunities. Very positive time for anybody to be joining electronics and computer engineering. So I'm going to leave it at that for now. I hopefully see you over the next few days. I'll hopefully see you over the next few weeks and months as you make your way through first year. I will certainly be part of your lives for your 2nd, 3rd, 4th and 5th year with us in the program. I'll be teaching you in second year, and we'll be doing some projects with designing of computers and doing some projects with sensors, and normally run a music or a robotics project in 2nd year. I also work with projects on autonomous vehicles, on drones, on robotics, that kind of stuff. So that's kind of my area. So for those of you who are interested in doing projects in that space, it'll possibly be me or one of my colleagues who also work in that space that you'll be working with. So look forward to seeing you. I hope you enjoy your time with us at NUI Galway. I hope you stay safe. I hope you take care of yourselves and take care of others. We'll be doing our best to try to take care of you. And like I said, if you have any issues or any questions or any queries or any comments or any suggestions, if you have any reason at all to get in touch, please get in touch. My email address is there, martin.glavin@nuigalway.ie. Probably best to send me an email. I also have a colleague, Maeve Duffy, who's the program director for electrical and electronic engineering. So we, the two of us, manage the two programs in the electronics discipline. You can also go onto our website, eee.nuigalway.ie. So I wish you the best of luck, and hopefully I will see you soon. So thank you so much. Thanks for taking the time to view this video.